This is where we left off in the previous video. We used the inverse operations method to find the value of x in this equation. Let's move on to the second method, which is the transpose method. The good news is that this method is as simple as the first one. We consider the same equation, x plus 3 equals 10. Before we actually implement the transpose method, we need to understand a few concepts. Look at this equation. We need just x on the left-hand side and we need to get rid of this 3. This 3, as we can see, is added on the left-hand side. Here's the first concept. Whenever an existing term is added on one side, we can transpose the term to the other side by subtracting it. In this equation, 3 is added on the left-hand side. So when we transpose it to the right-hand side, we subtract 3. We can write the equation as x is equal to 10 minus 3. So this plus 3, which was on the left-hand side, became minus 3 when transposed to the right-hand side. Remember, this plus 3 is an existing term. You're not adding or subtracting it. You're just transferring it to the other side by changing its sign. These two are actually the same equations written differently. The second concept says that if a term is subtracted on one side, we can transpose it to the other side by adding it. If the equation was x minus 5 equals 12, we would have transposed 5 to the right-hand side and added it to 12. The equation would then be x equals 12 plus 5. So here 5 was an existing term that was subtracted. We transposed it to the other side by adding it. This concept is valid for addition and subtraction of terms. When a term is transposed to the other side, addition becomes subtraction and subtraction becomes addition. Transpose basically means transferred. The concept is similar for multiplication and division. A term that is multiplied on one side is divided when transposed to the other side. Let the next equation be 2x equal to 14 that we need to solve. Since our aim is to have just the variable on the left-hand side, we should eliminate 2. And since 2 is multiplied on the left-hand side, we transpose it and divide the right-hand side by 2. We get x equal to 14 by 2. Similarly, a term that is divided on one side is multiplied when transposed to the other side. Consider this equation. X divided by 2 equals 7. We can see 2 is dividing the left-hand side. So we can transpose it to the other side by multiplying the right-hand side by 2. We get x equal to 7 multiplied by 2. So remember these 4 rules. If added, then it's subtracted when transposed. If subtracted, then added when transposed. If multiplied on one side, then it's divided when transposed. And if it's divided on one side, then it's multiplied when it's transposed. Now let's see how the transpose method helps us solve an equation. Let us solve the same equation we solved using the inverse operations method. (2x plus 5 equals 13). I reiterate, our aim is to keep just the variable on the left-hand side. So we transpose 5 to the other side. Since it is added on the left-hand side, we transpose it to the right-hand side and subtract it from 13. We get 2x equals 13 minus 5. This gives us 2x equals to 8. The next step should be to eliminate 2 from the left-hand side. Since 2 is multiplied with x on the left-hand side, we transpose it to the right-hand side and divide 8 by 2. So we get x equal to 8 by 2. That gives us the value of x as 4. We can see that we get the same answer using both the methods. The transpose method is actually the same as the inverse operations method. Just that instead of subtracting 5 from both sides, we transpose 5 to the other side. It's the same thing as 5 and minus 5 cancel out here, and all we are doing is subtracting 5 from the right-hand side. So we are avoiding a couple of steps to write the steps directly. In the inverse operations method, we use more terms to eliminate terms on the left-hand side. Here we just transpose them to get the same result. In our videos, we will be using the transpose method.